Welcome to OECD Podcast, where policy meets people.
Critical infrastructure like telecommunications, water, and financial systems are complex, interconnected networks with many, many moving parts. What happens when there's a long heat wave or a cyber attack? What about when a hurricane hits a coastal city like Miami? How ready is it for flooding, disrupted transport, electrical failure, contaminated water? Are its systems backed up? Has the city planned its roads and housing with an eye to sea level rise? And when disaster hits, how fast can a city get back on its feet? I'm Clara Young, and I'm speaking today with Igor Linkov, who is the Risk and Decision Science Focus Area Lead at the U.S. Army Engineer Research and Development Center. He's also an adjunct professor of engineering and public policy at Carnegie Mellon University. So thanks for coming to talk to us, Igor.
My pleasure.
In 2003, some trees brushed against a high-voltage power line in northern Ohio, and this caused a system shutdown there. The knock-on effects were this: a massive blackout in parts of Canada and 8 U.S. states, including New York City, that eventually cost $6 billion US. Igor, can you talk us through the domino effect of what happened and what we learned from this?
Yes, that blackout for me is a case where interconnected infrastructure react on something that is really minor. In response of these trees, it was minor software glitch that cascading in interruption, and 55 million people were without electricity for a long period of time. So the mechanism of this cascading failure in the system are not really well understood. And if you think about that, you're talking about just wires. It's fully engineered system. We should know everything about design and what is going to happen with this. But nevertheless, we were unable to prevent these cascading failures and massive impact on the society.
What can we do about it? Are we any better since 2003 at managing these interconnected systems?
We just beginning to realize that hardening of interconnected system is not going to help, because hardening one component may not prevent failures in other component, and critical function will still be paralyzed.
What do you mean by hardening?
Investment in something like, buying instead of one generator, 2 generators. You harden one piece of the system and you are not looking in other component. For example, if you have electricity but no water, it's not going to let you live for long, right?
Right.
Or if you have water but no way to pump it off the ground without electricity, this is interconnected infrastructure.
Exactly.
Is really important, and we need to understand connections of that.
So if just simply hardening infrastructure is not good enough, then what are we looking at now?
We need to understand how a system works, so at least how we can manage system in a way that we can recover from inevitable disruptions. Disruptions are inevitable just because it's nature of the modern time. We develop infrastructure to be efficient, and we are relying on computers, we are relying on many small things that may fail at some point, and then what happened after that needs to be mitigated. And we need to think not only about how to build efficient and functional system, but also how you recover from disruption.
Going back to this 2003 episode, one of the things that governments and systems operators hadn't thought about was the connection between the fuel system and electricity. For example, people couldn't get gas for the cars because electricity couldn't pump it. Do we have an inventory now or analysis of interconnected systems and how to be prepared for that?
We begin to think about that. If you think about the core of the problem, it's natural for engineers design systems that are going to work no matter what happens, right? And that's how engineering as a field operates. But failures are inevitable, so we need to start thinking how we are going to recover a system from disruption. And this is really new science. It's kind of blend of traditional engineering and system science that it's now just begin to be developed, and we're here in NIAC and OECD, and this organization is in forefront of building new science or integrating science to build what it's called resilience in system design.
What are, just to widen out our discussion right now, what are the biggest threats to critical infrastructure now that we face?
It's difficult to say. I believe, and again, I represent only my view, not views of U.S. government in this interview and answering this question in particular. I believe that we are start to rely more and more on what is called smart system. It's basically a system that are controlled by centralized computing power, and those systems may be affected by different software, hardware malfunction or adversarial attempt to interfere. So I think this is cyber threats probably the highest now in most of the civilian applications.
And I think that also with the Internet of Things and like the smart infrastructure that you were talking about, this is going to complicate things even more.
Absolutely. Yeah. Industry 4.0, our attempt to really make digital revolution is really, we should go that way, but we need to think about not only making system more efficient, but also more resilient.
You have said in previous talks that our critical services have been designed for maximum efficiency, but that doesn't mean they're designed for maximum resiliency. And sometimes the two can be in conflict. So what do you mean by that? And what's a good example of the two going in opposite directions?
Yeah, so basically we have limited financial resources. And for example, you may invest a lot of these financial resources in making efficient production. So a good example are car manufacturers in Japan. They were really efficient, very lean supply chain, one very efficient supply for one part. But then when Fukushima happened, many of the suppliers were not able to deliver. And what happened to car manufacturers was that they were basically stuck without any ability to quickly change suppliers. So then one of the small supplier for minor component of the car resulted in an ability for Toyotas and Hondas of the world to really deliver complete vehicles. So why? Because it was very lean supply chain. It was efficient. Under normal operation, it was perfectly fine. But when disruption happened, there were no plans to have another supplier or quickly figure out how to deal with that. And that was really miscalculation. And we keep doing that in many other systems. Again, resilience costs money as well, right? It's trading off efficiency versus resilience. So having two suppliers for the same thing instead of one cost more money. But it's absolutely crucial to think about how to make supply chain in the case of car manufacturer not only efficient but also resilient, and what should be trade-offs.
Right. I mean, it's interesting that you bring up the point about, it costs more money to make a system more resilient. I mean, who is going to pay for that? Do the private operators or the companies, will they pay more to make their systems more reliable and resilient, or where do governments come in that?
Again, talking as myself, I do believe we can make a business case for investment in resilience at level of governments, and this is where OECD may be very instrumental, or even at level of industry. Business continuity is really important. If you look at losses of insurance industry, now half of it goes for business continuity. So when something happens, company cannot continue. While only 20 years ago, most of the money lost by insurance industry was property damage, right? So when hurricane hit, you lost your building, that's where money came. Now your computer is flooded and you cannot work. Well, I'm simplifying, of course. So I really believe that even at the level of individual business, a value chain for a specific product, there is an important role for resilience. And actually, Resilience Shift, funded by Lloyd's, run by Europe, is really doing good work in thinking about business side of resilience. But that's in private side, and in governments, OECD and many agencies in the U.S. start to seriously think about how to deal with resilience.
One way to also take resilience more into account in urban planning and designing and maintenance is to turn away from just thinking about risk, because we talk a lot about risk assessment, risk management, but it's different from resilience. So what is the difference? I mean, if you talk about risk proofing a transportation system or energy grid, what's the difference between that and making it resilient?
When you think about risk, if you look at Oxford Dictionary, risk basically starts with fully functional system, and we try to minimize threat or decrease vulnerability of the system to prevent it from going down. So if you do right risk management, system will operate no matter what. That's a really laudable goal. If you can do that, it's really great. But unfortunately, it will be disruption that system will fail, critical function the system execute will go down. And at that point, resilience kicks in. Resilience defined by Oxford Dictionary is ability to recover from disruption. So starting point for resilience is disrupted system, while starting point for risk is functional system. Of course, if you think about what we like to get out of the system, we like it to function, but if it failed, we like to recover fast. And given complex reality of modern infrastructure, you cannot really prevent bad things from happening. They will happen. And thinking about both risk and resilience is of crucial importance.
If we take a concrete example, and when I say the word concrete, it's probably literal. New York Staten Island is designing a seawall along its coast to protect against rising sea levels. Now, if you could talk about, AC, not only just this, what's the difference between a seawall that's designed to be first and foremost risk-proof and one that's designed to be both risk-proof and resilient? How is the process different?
Yeah, again, talking as individual, not as Army Corps of Engineers that probably will build this wall eventually. If you think about risk management, you will try to build the highest possible seawall given the amount of money you have. You invest, you buy down as much risk as possible, and in the case of simple flood, again, simplifying, you build as tall seawall as you can. If you think about resilient seawall, you may not invest all your money in going up. You can go up to a significant degree, but then you start to think, okay, what if water overtop it? What's going to happen? And this is where resilience starts. So resilient seawall may be designed in a modular way that you have areas that are designed to fail and can be flooded, but then quickly recovered, quickly rebuilt.
How would you do that?
It's like, you can have different modular structures seawall. Like, for example, if you expect climate change, you can rebuild on top of what you have now. It's, of course, more complicated engineering design because you cannot really start rebuilding from most of the simple designs. You need to allow some features that allow to get higher. So it's extra cost. So maybe if you have the same amount of money, you will not be able to go as high as you could with simple design, but you may stop a little bit shorter, but invest in this resilience feature. Maybe you dedicate some area for controlled flooding. It's actually that was done in the past. Maybe you have like more sophisticated design of seawall that will fail, but can be quickly rebuilt rather than getting rebuilt from scratch if you have the simplest one. So those possible general type of consideration you could have in mind.
There's also, in a resilience approach, you would want to know what the community wants, or what they find is most important to protect or to bounce back from, too. Isn't that the case?
Absolutely. Again, you can think about two situations. In one, you have like residential community on the shoreline, and in another, you have sophisticated lab testing equipment, right? And you try to build flood protection infrastructure. Of course, you don't like to build seawall in front of a community that enjoy a view on the ocean, right? You can train them. So if there is a flood, they know how to deal with it. They can elevate houses. They can, have supply of food. They can evacuate. You can train community to respond to that. While if you have unique equipment, you by all means need to build better protection because you may lost a lot of value. So depending on the critical function of the system, you may decide, even though you have same amount of risk of coming floods, you may decide on completely different mitigation policies. And it's all driven by community needs.
Right. So maybe not just a wall,
Not
to
just a
put
wall.
resources into other things like training people.
Absolutely.
Okay. Let's turn to, I think for my last question, the whole globalization. And it's such that when critical infrastructure is hit in one country, is likely to impact other countries. Because we share, as you gave with your example with Toyota, we share supply chains, goods, services, and information move back and forth between countries on the internet. How good are governments at working together on these threat and disaster issues?
I hope OECD can help to make governments work together better. I was recently engaged in a meeting at the USAID on global health. And it's really interesting to see discussions because, Ebolas of the world, they don't know political borders, right? So you can have a country well prepared for disease epidemics, but if it's coming from just neighboring countries, it may be a completely different story. So this global impact of global threats in interconnected countries with infrastructure and people traveling, connecting, communicating, we are not prepared for that.
Okay, well, thank you very much for speaking to us, Igor.
Thank you very much. It's my pleasure.
And thanks for listening to OECD Podcasts. I'm Clara Young. To find out more about what we've been talking about, read the OECD's Good Governance for Critical Infrastructure Resilience.
To listen to other OECD podcasts, find us on iTunes, Spotify, Google Podcasts, and SoundCloud.com/OECD.